Hi everyone. My name is Mark Winter, and together with Fahad, we are going to tell you about FRINT, a JavaScript library that we have been working on. Before I start, I just quickly want to say thank you to the organizers for inviting us. We're really happy to be here, and I hope it's going to be interesting. So what we would like to do today is I will quickly give you a very short introduction to the company where we work at and the website that we have been working on, and talk about what were the main challenges that we wanted to solve with this library. And then Fahad is going to talk about all the technical details of how it works. So we work at a company called Travix, which is an online travel agency based in Amsterdam. And the main profile of the company is selling flight tickets.
Yeah, it's good.
Yeah, selling flight tickets on our websites under different brands. For example, cheap tickets and budget air. And these brands are currently present in over 40 countries. I think the budget air brand is also present here in Poland. And I will quickly show you what our website looks like on which we are working, and tell you a bit about what was the main challenge that we wanted to solve or tackle. So this is the main page of our Dutch cheap tickets website, and this website implements a pretty typical e-commerce shopping flow. So on the main page, a customer can search for a flight by entering their departure and destination. Then on the next page we can see the flight results, we can select the flight, and then we have to enter all our personal details to do the booking. And then on the final page of the flow, the customer can buy some extra products, for example, insurances, car rental, and hotel. So this is a pretty typical e-commerce website. In terms of the technologies that we are using, this website is built with Node.js and React. And the way we are delivering and deploying this application is that we are using Webpack to bundle the whole application into a static JavaScript and HTML bundle. And in the end, the deployment is basically just copying those static files behind a simple Nginx server. And I think this is a pretty typical setup for React-based web applications and single-page applications. And doing the bundling this way has the advantage that we can bundle and minify the whole source code of the complete application into one single file, and then also the browser has to do only one single HTTP call to get the complete application. And because everything is statically bundled, the end deployment that we are doing is really reliable, because the end result is very, very simple. It's basically just an Nginx server with a couple of static files behind it. On the other hand, managing the complete source code of this application in one monolithic repository and doing also the deployment in one monolithic step has also some drawbacks. One of the drawbacks for us was that as the site became more and more complicated, the repository also grew and became more complicated, and it was more and more difficult to work with it. And it was easy for teams to basically step on each other's feet and cause merge conflicts, for example, when working on this monolithic application. And because the deployment is also happening in one single go, that means that if one of the development teams introduces an issue or a bug, then the whole deployment pipeline is blocked until they fix it, and none of the other development teams can deliver anything. And what we wanted to achieve is to be able to take out components of this website and extract them into completely separate, isolated repositories, and also to be able to deploy them independently, and then on the website load them at runtime dynamically and inject them into the UI. So this is what we wanted to solve. And taking a big monolithic API and cutting it up into smaller parts is a pretty straightforward thing to do on the server side. For example, if we think of microservices, it's not that it's necessarily easy to do. Having many distributed APIs has a lot of challenges, but at least technically the way to split a big API into multiple smaller ones is a pretty straightforward thing to do. On the other hand, on the front-end side, in client development, there is much less of an established way of how to separate a big website into multiple independent, isolated components. For example, on this page that you can show here, these components which are selling various extra products were very good candidates to try to somehow extract them and try to develop and deliver them separately, because they are completely self-contained and independent from the rest of the website. And this was one of the main points of motivation that we wanted to solve with the library FRINT. And now Fahad is going to tell you about all the technical details of how that works. Thank you.
Thanks, Mark. Can you guys hear me? Yeah. Cool. First of all, I would like to thank Piotr, and hopefully I aimed you right, and Piotr and WarsawJS, the organizers, for inviting us. So, how do I put this in a pocket? Yeah, just a minute. I'll just keep it here. Thank you. And yeah. So basically, what is FRINT? And so first of all, it's an open source project that we built at Travix for solving the problems that we uniquely had at Travix, like Mark suggested. If it's really difficult to just come up with a single line and say what FRINT is, but we came up with a tagline saying that it's a modular JavaScript framework that allows you to break your big monolithic application into smaller apps, and it helps you build apps in a scalable way that is also reactive. That's a lot of words to understand in one single sentence, so I'll go through all of them. And the way we develop this framework is, it's a collection of multiple packages, so each package is doing their own thing only. So we got really inspired by the philosophy that just do one thing simply and do one thing well, and if it grows into something bigger, create a new package. And it's built primarily for the needs of Travix, and but even though we built it primarily for solving our own needs, we built it in a way that is generic enough to be used anywhere. The framework is actually environment agnostic, so it can work in the server, it can work in the browser, it can also work in the command line, and we also have a React Native integration, so you can even run and build iOS applications. And the core is very, very focused into building, into providing a very small set of features, so you can build more tools on top of it. So we don't want to bloat the framework with more and more features, so just provide enough so that we can have an ecosystem around it. And it's also stable since version 1.0, which was released in March. And it's already in production, we are using it ourselves. So anytime we have a bug, we are the ones who are facing the trouble, so you can really rely on it. And one other important thing is it's rendering library agnostic. So FrintJS itself has nothing to do with rendering. So it doesn't care if you use React or Vue or React Native or even Preact. So it just works with everything. And yeah, so continue. So these are some of the packages that we have in the monorepo, and we also have some outside of the monorepo. So we went with a monorepo architecture because it was easy for us to develop multiple packages in one single repository. So whenever we needed to release something, we could just do a single release, and all the packages are published to NPM. And so to start at the beginning, the first package that we have is called FRINT. That's the core of the framework. All it does, it allows you to create apps. We'll come into the concepts in the next slides. And then there is React integration that we use ourselves. It's called FRINT React. Then we have a FRINT React server, which is for server-side rendering of React applications that are using FRINT. And then we have FRINT Store. So how many of you know Redux here? OK, that's a lot. So FRINT Store is a Redux, but we are also big fans of RxJS and reactive programming. So FRINT Store is built with RxJS. So it's once you already have RxJS, you don't really need to load another library like Redux, because it's just one function is enough. So we'll come to that too. And then we have FRINT Data. So that's something we developed a few months ago. So it has nothing to do with Frint actually. So it's just a prefix that we are using in the monorepo. So it's completely independent. And it allows you to create reactive data structures with schema. So if you have any like typed definitions without using TypeScript and you don't follow that, it will just throw an error telling you like, okay, it failed at this unique field. And then we have Frint Router for building single page applications. Again, this is just like a reactive ES6 class. So once the instance is there, so it will listen to like browser's history changes and it will keep streaming new values to you. And so it has nothing to do with rendering. And then we have additional package called Frint Router React, which is like a set of React components. If you have used React Router, it has a route, it has a switch, components like that. And it complements Frint Router package. Then we have Frint CLI. That's the command line tool for Frint. So it allows you to access the Frint command in your terminal. And it itself is very pluggable, so you can extend it with more subcommands. And right now, in the base Frint CLI, it has a new subcommand that allows you to scaffold new applications from the examples that we have in our monorepo. And since we use it in production, we are very, very strict about backwards compatibility. So let's say in the Q1, we deprecate some features. We must support it in the second quarter too. And by the third quarter, we are sure that, okay, we can remove this feature entirely. So this gives our engineers at Travix like at least 3 months period to like migrate their code. Otherwise, things just go out of hand. And outside of the monorepo, we also have like integrations like Frint Vue. So if you have a Vue.js application, you can use a Frint Vue integration. And there's Frint React Native, so you can use Frint in React Native apps too. There's Preact, and I have no idea why I typed Frint Vue twice, so ignore that. And so the need for Frint, Mark already explained some stuff. So if I come down to like one word, it's modularization. So we have a big monolithic front-end app, and our requirement was to like split into smaller isolated apps so that each product teams can actually handle their own code only in their own repository. And our server could then decide, okay, I need, for this particular user, I want to render cars, so I load cars.js. For another user in another website, we have insurance, so we load insurance.js, and they just render in the right area that we define in our website. So the setup in our company is like this. So we have multiple product teams. They are always working every day, shipping new business features to our websites. And then we have one support team. It's sometimes called a support team. Sometimes it's an R&D team. So we basically build the tools that all our engineers can use and ship features with. And the responsibilities are like product teams are always worrying about their own code and their own features and own business cases. And this allows them to like have more freedom if they have the isolation with FrintJS apps. And they can then host their own code in their own repository. So our main server is only concerned with loading the right scripts at the right time. And so again, like why Frint, like why not something else? Having a framework is not just creating something new, but it also helps align the development of like multiple teams together, because we are growing like crazy. We have like more than 50 plus front-end engineers working every single day pushing code, and it will grow over time again. And this helps us align. And also we want to establish the same way of building apps, so that let's say one developer is moving from one team to another so that they can understand the code. So it shouldn't take too much time to help get you started. And overall, it really gives us a solid foundation to build upon. And also, since the support team is taking care of the framework, and also it's like open development, it doesn't matter if you're in a product team or support team, you are always contributing to open source project. And it helps us to keep things backwards compatible, because everything goes through the process that we are aware of. And it's open source and well-maintained documentation for all, so it doesn't matter if you work in team A or team B, everyone gets to have access the same way. And another big thing is code splitting, which is the concept of having apps and child apps, which I'll explain in the next slide. So imagine this is the main website. It can be our own cheaptickets.nl or example.com, doesn't matter. And it has 4 bundles in this case. So the first one is vendors.js. This one would have things like React, Lodash, RxJS, and all the Frint packages. And then we have a root.js. This is the primary root app. So this is something that is rendered to DOM directly. So this is the base application. So this is the green part that you can see in this slide. And now dynamically, the server can decide, I want to load app1.js or app2.js, or it can be like anything, infinite numbers. And those apps, those bundles are actually being loaded into the browser, and they said, okay, the root app already has a region defined. Region are like areas that you define with React components or Vue, doesn't matter, in your root application, and give it a name. In this case, you can call this region a sidebar. So you say import region from Frint React and then embed the region in your JSX. And you give a name prop, call it sidebar, and that's it. Root app doesn't need to know anything more. So its responsibilities end right there. Now, the server can decide, okay, based on some logic, condition, whatever, we want to load app1.js and app2.js. And one of them, let's say, happens to be targeting the sidebar region. It can be a footer region too, and header, doesn't matter. And as soon as they're loaded, they get rendered directly in the sidebar region. In this case, both are targeting sidebars, so you can see app1 on the top and app2 at the bottom. You can also like configure the ordering if you want. But still, I'm not getting into the code. I'll wait a bit. Some questions arise like, why not just use React or AngularJS? Like, why even build FRINT? So about the React, I have to say that FRINT is not a replacement of React in any way. It actually complements React. React is just for rendering, and FRINT is React as a rendering mechanism. So FRINT has no opinions about what rendering library you use. We use React. That's why we built a React integration package called FRINT React. And it allows you to like build applications in a decoupled way, and also FRINT allows you to give your application a structure. So the most of the logic and stateful stuff is kept out of your component layer. So component layer is most like full of stateless components. I'll come to that too. And when it comes to AngularJS, it's like a full-featured framework, and our monolith was already built with React like more than 3 years ago. We are very early adopters of React, and we are still sticking to it. We love it. And starting from zero was not an option because it's such a huge monolith. We cannot just like dump it and like start from scratch. So that's one of the reasons, like we need to build something progressively. So it worked for us, it's still working for us. And if you already have a React application, you can still slowly inject FRINT into it. And so now I'll go into code stuff. So the first concept that all of us need to understand is everything is an app. So the main core FRINT package, it only allows you to create applications, nothing more. But what is an app really? So when it goes to like the scalability stuff, like code splitting and all, like having child apps, that's where things get a bit more complicated. So right now I would just focus on like creating a root app. That's the only app that you have in the browser. And so what does an app have? It has a name. You give your application a name, like, okay, this is my app, my WarsawJS app, or whatever. And apps have dependencies, like you can put stuff into your app. And the stuff that you put in it are called providers. So this is something that we took inspiration from Angular 2. So they really have a solid dependency injection API called via injector class. So, but that's like too much investment, and we didn't want to like go into a full-featured framework like that. And so we got inspired by that, and we built our own DI system. And so we need the FRINT package, so we can just do npm install say FRINT. And this is how you create an app class. So you import the create app function from the package FRINT, and then you call it, and the options that you pass to it is the first option is the name. You give it a name. It can be a my WarsawJS app. And then in the providers, it's an array. It's an array of all the dependencies that you have for your particular application. And in this case, I'm saying that, okay, I have a dependency called foo. I give it a name, and the value is a string, as simple as that. So now that the class is defined, I can instantiate it, and now I have an app constant, which is the instance of my app class. And once it is alive, it's already executed, I can get the value of foo by doing app.getFoo. That's basically the core. It's like there's not much more than this. But that's just like the FRINT layer. So how does it even play with React in this case? We can get into the component layer now. So the examples that you're going to see are going to be focused on React, but imagine that the same API can be used for Vue.js too. So you don't have to be tied to React. So we can just create a plain component. We import React from React because of JSX. And here it's just a stateless component. We give it a name and export it from the file directly. and it's printing out hello world. Nothing fancy. It doesn't even have props. So how do we let our application know that we have a component that we want to render at some point? We set it as a provider. By convention, we give the provider name component, and the value is my component that we just imported from the module of the React component that we created. And then we continue with the app instantiation in the bottom. But still, it's not rendering anything. We just let our app know that, okay, we have a component that may or may not have more child components, but that's it. When it comes to rendering, we need to get a React DOM that is needed for React itself. And then we have the React integration package called FrintReact. So this is how you render a FrintJS app with React. We have the app instance that we had from the previous slide. And you can see that we are importing a render function from the package FrintReact, and then passing the app instance instead of the component that a regular render function from React DOM would have. And then the second argument is the DOM node where we want our app to mount itself on. It's similar to React DOM, but the package name is different. So you may ask, like, why even not use React DOM directly? Actually, FrintReact is using React DOM internally, but when you pass it through the render function coming from FrintReact, it sets the app instance in the context API of React. So if you have used Redux with React, you know that there are components like Connect, higher order component that allows you to access your store. So we have also a higher order component in our packages, which I will explain in the next slide. And since the app instance is in the React's context, it allows the higher order component to like compute more stuff for you. So this is the rendering part. And now it's about observed components. But before showing you the slides, I'll take you to the blog post that we wrote a few days or weeks ago. So this is called a deep dive into, the image is not loading, doesn't matter. Deep dive into observed components with React and Frint. So in FrintReact, I'll increase the font size. We have a higher order component called observe, and this allows us to access the app at any level in the components tree. So imagine we have a simple my component that receives props, and we can make it observed component by calling observe, then pass a function where we would generate the props that we want our base component to receive, and then of course like wrap the original stateless component that we wrote before in React. So that's the simplest form of the API. So if you used Redux, then you can just replace observe with connect, and it just looks exactly the same. And there are multiple ways to generate your props. So imagine you want to access some values synchronously from your app instance and compute it and then generate it and pass it as a single plain object. That will be the props of your base component. So you can do it like this. The function that you pass to your observe higher order component gives you access to the app instance. So from here, you are totally free to get any provider that you have defined in your app instance, process it further, generate the object that you want to be made available in your component as props. You can do it all here. So that's the synchronous part, the easiest part. It also has, so this is what I was gonna show. Like you can return the app name, like app.getName returns you the my WarsawJS app, for example. And the foo is here, the foo provider that we set in our app class before, which was totally living outside of React. Now you can use it here. And now in your base component, you'll be receiving app name and foo as props. And the good thing about this is all your components, React components, would be built in a totally stateless way. You would not be needed to like access the set state or the context API, nothing. Everything is like pure and functional. And this is where RxJS comes into play, where you can also stream the props. So I would like to ask, like, how many of you are aware of the concept of observables with RxJS? Okay, so just to explain simply, how many of you actually work with promises? Everyone, great. So promises emit a single value, and they end right there. Observables keep streaming value. It can be like 0, it can be 1 value, it can be 5 values, infinite, doesn't matter. And they also can also complete. And so imagine intervals. So if you do an interval, you could do like a window.set interval and pass a function, like and wait period, like you can wait every 1 second or 2 seconds. So this can be expressed with RxJS like this. You can import RxJS/observable/interval, and when you call this function with a waiting period, like, okay, this is the delay, or I don't know the appropriate word for this interval, and so it will emit a new value every second. And this can be visualized like this. So here I will start presenting again. So in the first second, your props will be interval equal to 1. In the second, interval will be 2. In the third second, interval will be 3. How do we make sure that this streaming props is actually fed to your base component so that you write your main React component as just a stateless component, you receive the props and render? That's where your responsibility should end as a React developer. Then the FrintJS stuff takes over. We can do it with observe, this page here. So first we express interval as an observable here, and then we need to make sure that we map it in a way so that it's props compatible object. Here, interval emits an integer, a number, then we are mapping it using lettable operators in RxJS, which was introduced in version 5.5 like a month ago. So we are piping it and saying that, okay, when I receive a number, I want to map it to an object. That should be interval equal to x. And now we have a props stream, a props observable. So how do we connect it to our base component? This is something that we can do with our observe. So instead of returning a plain object from inside the function, we can just say that, okay, prepare a stream of props with RxJS or your preferred library and return the observable. You don't even subscribe to it yourself. That's not your responsibility. FrintJS will take care of it. So you just say that, okay, I have generated a stream, and it may or may not update over time, and your component will automatically react to it. So you just declare things once, and everything is reactive. And you can also access the parent component's props that are passed to your base component. So there is a second argument that you can use. That is the prop stream from parent. This is a bit advanced usage. I think 80% of the use cases you won't even need it, but we have this in the API. Now you can manipulate this in any way you want. RxJS is, to be honest, is not easy to get into. You really have to think in a different way. So thinking in reactive way is like something that takes time. And I myself am still getting used to it. So we actually built some helper functions from Frint that allows you to build a stream of props that you can use in your components. So this is an example here. Can you all read? Okay. So here, instead of manipulating with RxJS observables like yourself, you can just import another function that we have and ship from Frint React package called stream props. So it's a very functional chained way that you can use it. So you have the function that already gives you access to app instance and props. So here, you just return stream props, you call the function, and you can keep on setting synchronous values that you have. You can have key value pairs. So here, I want to have a foo prop that has a value, foo value. Then I am setting a plain object here. So it's like directly a key value pair. So bar will be a prop in the final props object. So these are all synchronous. Now things become a bit reactive. So these are working with observables. So the interval example that we saw in the previous slides, so how can we map it to an interval key in the props object? So we just pass interval stream as the first argument, and all the additional arguments that comes after it will be treated as like mappers. Get the integer and then map it to an object which has a key interval. And you can do it with more stuff, like you can even manipulate the props coming in from the parent component, map it to some object that is convenient for your base component, and just end there. And once you are done like setting stuff, you can just do a simple .get $, So this is like a convention, like whenever you have a function or method ending with $, it represents an observable. So that's why we follow that. So you can just call it, and that will give you a final observable that you can just return from this function. And what ultimately happens is your base React component, which is like a stateless component, will be receiving 4 props. One is foo, which was set synchronously, bar, which was again set synchronously, and then interval, which will keep on updating every single second. And then it was buzz, which is coming from the parent props. It was again an observable that was mapped in the runtime. And interval and buzz are like the reactive props, and these are the synchronous props. And stream props with observe higher order component, you can like take benefit of both. And these are like extra stuff. So sometimes you may want to start your props with some default values because some observables may take time. Imagine fetching something from your server, like a fetch using fetch, and it may take 5 seconds, but you want your component to already have a default value. So stream props actually accepts an argument, which is a default props to start with, and then when the other reactive observables actually come up with new values, it will be overridden, and a new merge props will be passed to your base component. So that's like streaming and RxJS part of it. And so the benefits is like, now imagine when you have some complicated logic to deal with at your component layer, you can like totally extract it out of your React component and just handle it at just JavaScript level. And if you want to switch from React to Vue for some reason, you can just like switch the package from FRINT React to FRINT Vue and update your components, which are already stateless. They're easy to test, easy to maintain. So the burden from the rendering side and the component layer is like a lot less. And the logic gets more and more heavy on the provider level because they are meant to be stateful. And so yeah, that's the observe higher order component. So now I will go back to the slides. And so yeah, I was just drawing some diagrams like observables keep streaming props, and components can like fire some events. And this is the subjects. This is a bit more complicated, so I'll skip. And yeah, so this is streaming. So now comes the regions part. So this is where the apps, root apps, child apps thing come into play. So like I mentioned in the previous diagram, like regions are areas where we that we just define in our application, in our component layer, and just give it a name and forget about it. Like they do nothing more. It's only when like child apps get loaded and register themselves to root app that they render. So this was the diagram before. So defining a region in a root app is pretty simple. So we have a region component that is integrated with React. So we have the FRINT React package for that. And you can see in the bottom of the component, we just embed the region component and give it a name using a prop and call it sidebar. That's it. And so to load some child apps, we need to understand the difference between root and child. So a root app is something that you render to DOM yourself manually, and child apps are never rendered directly. You register them as classes. And so this is how it works. You can see that I'm importing root app and child app in this file, and I'm instantiating root app and rendering it to the DOM node, and that's where the root app's stuff is done. And in the last segment, I'm saying that I have access to the root app instance via window.app. It's a global variable. And then I want to register a child app. And the second argument that you see here is that we can pass additional options. And we are saying that for this child app, we want to target the sidebar region. It can be like footer, header, doesn't matter. So as soon as the region is out, the child app is not rendered anymore. As soon as the sidebar region is like shown, maybe via a toggle button, it will come back again. So that's how it helps with the splitting. So the reason we had this global variable is because if we split our apps into like multiple bundles, let's say root.js, app1, child app1.js, child app2.js, when they get loaded, they can access the root app via this global variable and register themselves, and that's the only reason. So there is no other reason to have a global variable unless you need this code splitting technique. So cascaded is like sometimes you may have providers in the root app that you want your child apps to share. So a good example would be if you have a single Redux store in your React application and you defined it as a provider in your root app, but you also want your child apps to share the same store, you can just cascade it. So it means that when the child apps are observing their components and they have access to their own app instance, they can do an app.get store, for example, or Redux. They will be sharing the same store that was defined in the root level. And yeah, so I can show you a quick example. This is using FrintCli. So you can just install FrintCli globally and then run frint new, the directory where you want to scaffold your application, and the name of the example that you want to scaffold. And then just cd into it and then npm install and just npm start, it will open up the application right away. So this is a working application that we have here. This should be here. So it's totally blank right now. There's a reason, because I totally deleted all the script tags that we have. So in this example, we just loaded vendors.js. This has all the third-party libraries like React, FRINT packages, and stuff. And then we have some commented codes. So the first one is the root app that we have. This is a pre-bundled JavaScript file, but it's all on our monorepo. You can check it out. So let me just uncomment it, save it, and go to our page. It just refreshed automatically. So the root app have main column and the sidebar column. And they actually have some regions defined. I can show you in the code level. So this is the root app. This is the component. And you can see that I have a region defined as main and a region defined with the name sidebar. So that's where our root app stopped. Like, it doesn't even know about any child apps that we may or may not have. So it's totally oblivious about it. And so what we can do is we can just uncomment this line, and we are going to load our first child app that has a name foo. And it's actually targeting either of the regions. I don't remember right now. So I'll just save it and go to back to the browser window and see what it does. So all of a sudden, the same application, without even rebundling our root app, we have a foo child app that's rendered in the main area. Simple as that. And it has its own logic. It has its own dependencies as providers. It has its own store, so I can increment the number here. I can decrement it. And it actually also has some extra line here that says that I'm expecting to access another child app called bar, and that should have some information about color. But it doesn't exist, so it has graceful API. So it means that if the bar app is not loaded yet, so you will just get undefined and it will not break your application. So what happens if we actually load the bar app now? So let me uncomment this line here, save it, and this one is supposed to target the sidebar region. So now we have a bar app on the sidebar already rendered with its own state that is handling changes of colors. I can set it to red, set it to green, keep changing, and you can see that when I set it to red and green here, it's also updating its UI on the left side, which is a totally different app. They're actually accessing each other reactively by their names. And if I keep updating the number here, you can see that it's also updating right away on the other app too. So it doesn't matter if your app is loaded or not. It's reactive. It has a graceful API. So if it doesn't have anything, it will just not do anything. And that's it. And yeah, so that was the region part, how we split our apps into small isolated apps. Example app, so state management. So it's very common that everyone that uses Redux, React is into Redux, and it's really awesome. It really established some good ways to have state management in your applications. We think, well, the Redux community thinks like there is only one single store in your React application, and that really works great. Our thinking is a bit different. FrintJS thinks like all the dependencies of your application are defined as providers. So Redux store can be seen as a single provider in your app. You can have many other providers. Imagine if you have a single page application and you have a dedicated service for like listening to the history API changes in the browser, you can have a router provider. You can have something else. And so we also have like a performance budget, and we try to cut down on external libraries. And so we built Frint Store, which is just using RxJS internally for creating a reactive reducer-based store, just like the API of Redux. We just have less features. We don't have middleware support, so that everything is same across all the apps in our teams. And you can use it like this. Again, Frint Store is not a mandatory thing for you to use. You can or may not choose to use it. So we just define a provider in our app called Store. And there, we use useFactory. UseFactory is used when you have to generate a value during app instantiation time, or if you have a known value, in that case, we use useValueKey. That was used for setting the component, because component doesn't need to be processed further. In this case, we are creating a store with our root reducer, which is the same as your Redux reducer, and we are instantiating it. And now when we do app.getStore from the instance level, you're going to get the instance of the Frint store that we have. So that's how you set the store, and from the observe higher order component, you can then get the store, listen to the state changes, and stream the values to your components. We also have server-side rendering. We have Frint React Server. So this also follows similar APIs to React DOM, the server side. So it has render to string function. And once you instantiate your app, you can just say render to string, pass the app, and you have a full stringified version of your HTML. And what else? We also have some other projects coming up. We are very open about our development. So don't think like we just open source something. It means like we build something and dump the code on GitHub and forget about it. No, we actually have open development process. All our ideas and stuff are actually submitted on the GitHub as issues. And we have a proposal system. So for example, we have this experiments proposal that is defined as an issue. So we say that, okay, what is the current situation? What is it that we are trying to solve, and how can we solve it with the API? Then we have like more feedback coming from our own team members, sometimes external developers telling us like how we can do it better. And once the refinement is done, only then we build stuff. So it has been happening for more than 6 months now. So even if you have some ideas, just let us know on proposals and we'll take care of it. And so Frint experiments is for like declarative A/B testing. So we have some A/B testing requirements that we want to unify across all the teams. So this will also happen. And also localization is something that we still haven't tackled with Frint itself. So that will also something that we'll look at in the future. And I will also mention about other packages. So I told you from the beginning that Frint is rendering library agnostic, and you can use Frint with Frint Vue. So the same observe higher order component, stream props, and region component is the same in this Vue layer too. So how does it look like? You can just import render from Frint Vue, and then call the render function like this. You pass the root app instance and give it all the options that your Vue instance may need. So here it's a shortcut. You are just telling it the element name, like where we want it to render. You can also pass the same options that you can pass to the Vue constructor. We also have Frint React Native integration. So if you are using React Native and want to embrace reactive programming with Frint and also have a clear structure with providers, you can do it right now. You can just import the register function from Frint React Native. This is what sets the app instance in the context of React component, and then uses app registry to register your root component. So you just instantiate your app and register the app, and your iOS app is already ready. So contributing is really easy. So if you feel like it's something that helps your use cases, it doesn't matter if it's a small application or a big application. I'm pretty sure it has some benefits that you can bring to your projects. So you can take a look. We have lots of documentation on the website. It's on frint.js.org. So you can just go to the documentation tab, and you can see that all our packages and we have guides, we have the advanced guides, and all the packages are like on the left side. You can just click them and see the API docs. And also we are very active on the blog. We have a Medium account, so it's medium.com/FrintJS. So here we write a lot of articles about how you can use Frint with React, with Vue, with Redux, how to stream props and things like that. And then you can really help us find bugs, if there is any. I'm sure there are. And you can help out on issues, you can improve the documentation, or you can just let us know like what are your use cases, how it can like help you, and maybe we can figure a way out. And so these are some of the links. Docs are on the website, on GitHub, we have the repo, all the packages are already on NPM, and we are very active on Twitter too, so whenever you have a question, you can send a message there, we'll come back to you. We have Medium presence. And we also have REPL, so if you want to quickly try out FrintJS without even installing anything, you can just go to this URL on our website. I hope it works. It's loading. Yes, so, oh, come on. Yeah, so you can see it has an observe component that is similar to the examples that we saw before. It's showing you the app name, and the interval is also there. It's like reacting every second. So the code is all there. You can find all the files on the left side if you go. And yeah, that's about it actually. And if you have any questions, you can just let me know.
So questions? There's one.
I hope it's a good one.
Okay, so I like the region feature. It's actually very neat, and I think it's the best feature of the framework you just shown, because it's actually I think it's the framework. So regions are your framework, and the rest is like helpers. But yeah. Okay, I wonder about one thing, because apparently if an app registers itself for a region name, and that given region name becomes available, so it renders eventually, then the app shall mount itself in the newly instantiated region, right?
That's the difference. So when you register an app, it actually gets registered in your root app, and the instance is already alive. So the app is already computed, executed, and the providers are already existing. So what happens with the region coming into Vue is it's just a component, like a React component, and then it communicates via the React's context API, all happening under the hood, so that you don't have to deal with it. So it checks that, okay, what are the current list of registered apps that I have? Is there any app that is targeting sidebar? If yes, give me the instance, which is already existing, and then get me the component out of it and render it. So it's the same app that is rendering.
Oh, okay, so I was actually gonna ask about that, because I was wondering if the apps were phasing in and out of existence and being constructed and destroyed every time. And I see, so they're eagerly instantiated and just mounted. Okay, that's
but there's an option actually. I'm really glad that you asked this question. So we also showed you the checkout flow that we have. So it has like search results. So imagine all those results, they're looping. It's the same component, like search result component, let's say, item. And if each of those items can have a region that is unique name, saying that search result item, that's the region name. So if we have a child app that we expect to be loaded in each individual item, we can say that, okay, it's a multi-instance app. So it's a setting that we already have, and we are actually already users of this feature. So it means that in those cases, the child apps are not eager, and they will not be instantiated. They will only be instantiated once the region is loaded.
But they're not evicted at any time, like they live on forever.
You can even remove them.
Oh.
So it's like the API is all there.
Great, thanks.
Yep.
Okay, any other questions?
You mentioned server-side rendering and code splitting.
Yeah.
Other than that, what's your take on web performance, and not just in the runtime, but when you initialize the app?
One thing I have to mention is we never server-side render the child apps. They are loaded always in the runtime. And the only use cases that we have for like stringifying the HTML from root apps is just for root apps. So it's something that we already have in the file system. So once we go through the app, like let's say the Node.js server is running, we already know of all the components that a root app needs, and only that layer is like rendered in the server side.
Right, and isn't this an issue for your users?
It depends, because the only place right now, at least for us, where we are splitting the code is in the checkout flow, and that's more like a single-page application that we have. So it means that we are already dependent on JavaScript for like rendering the stuff, but we also have content pages which are like pre-rendered. So in those pages where search engine comes in and starts scrolling us, we never like do child apps. So it's child apps is like more like an appy thing. So if you have an application-like environment, in those cases it makes sense. And other thing I also want to mention, not directly related to this, is it's the root app, child app concept is not really tied to like rendering only. I told you about FRINT, the command line tool. That itself is actually built with FRINT. So the new subcommand that you see, FRINT-new, FRINT space new. So new is actually a child app that gets registered in the runtime, and then it exposes a new command. So if you are building like your own subcommands in your own application using FRINT, you can even extend like FRINT WarsawJS, for example. So it's like very modular in that nature.
Great, thanks.
Yeah.
Okay, so one last question from me.
Okay.
Can you tell me, have you ever tried to compare this technology with Neutrino, this by Mozilla?
Neutrino, I don't think I have tried that actually.
Okay, well, just wanted to ask because I thought that maybe it does some similar things.
Isn't
okay, but
okay.
right, just.
Yeah, that's like building stuff. I can take a look.
Okay.
Yeah.
Okay. So thank you very much. Big applause.
Thank you.